Happy December 17th. Today I want to do another sort of historical discussion about particle physics, and this is what is known as the November Revolution. Now this was in the 1970s, I'm afraid I forget the exact year, and there was a lot of interesting discussions going on. So physicists had this idea of a quark model that explained all the different hadrons. And the problem was they had hundreds of different hadronic states, and they sort of formed these different patterns, and some people said it was like stamp collecting or botany. You know, you discover a new particle and you put it into a table somewhere and you try to make some kind of pattern between them, but really it's just collecting masses and collecting facts about these things without actually explaining them. And over the years people developed what's known as the quark model, and some people call it the parton model. And the idea was that you have these fundamental fermions called quarks, and you combine them in different ways, and they give you the different mesons and baryons that were being seen. And it seemed to do very well at explaining what happened. It actually led to very interesting sources of symmetry. Now, one of the examples was, for a long time we had the up, the down and the strange quark, and this suggested there should be an SU3 symmetry associated with these three quarks. Now it turns out there was an SU3 symmetry, but this came about from the colour of the quarks and the colour of the gluons, and I've mentioned the gluons in a previous video. There was some confusion about where this SU3 symmetry arose from, and it came from the colours of the quarks and not from the flavours of the three lightest quarks. Now, one of the predictions made by the quark model was that there should be a fourth quark called charm, and this was actually discovered, and it was discovered in two different labs at the same time, and it was confirmed by a third lab. And when they discovered it, it was discovered in the J psi, which I mentioned yesterday. So if you remember, they had this falling distribution of the invariant mass of two muons, a huge peak, which is the J psi, and then it falls off. And this huge peak was evidence of the charm quark. This was the final part of the second generation of matter, and this basically confirmed the quark model. And this was useful in lots of different other areas as well. For example, there was the problem of the K0 decays. So the K0 is a meson, and it can decay to two muons, and it can only decay to two muons if there is a charm quark, and if the charm quark has a high mass, higher than the strange up and down quark masses. So when it was discovered, and it was seen to be consistent with the decay rate of K0 to mu mu, this gave further support to the quark model. And very quickly, scientists got a lot of confidence in the quark model and started to develop it. And then quite soon afterwards was when we had discovery of the third generation of matter, with the tau and the bottom quark. And that's why they realised that they needed a top quark. So this November Revolution basically put to rest any doubt on the quark model of matter. And it must have been a fantastic time to be around, to actually see all the confusion of all these different hadronic states and all these different models to try to explain them. Very quickly, the quark model emerged as the best model, and then very soon after that we had the standard model of particle physics. So that is what I wanted to talk about today, the discovery of the J psi and how it led to the November Revolution, and how that basically gave birth to the modern particle physics that we deal with today. Okay, I'll see you tomorrow.